Hello and welcome back to the second part of scatter plots and linear relations. We are looking into a couple of examples together, and here goes the first one. In this example, we'll practice how to draw a line of best fit and find the equation in a scatter plot. Now, the scatter plot shown here describes the relationship between the rebound height versus drop height. So, rebound height goes on the vertical axis. It's always y versus drop height, which goes on the horizontal axis, so versus x. For rebound height, we have the variable r, so we have r versus variable h for the drop height, so versus h. Now, the first question is asking us to draw the line of best fit. So what I would like you to do is take a look at this scatter plot and think, is there an obvious trend that the scatter plot actually will follow? So, in my opinion, there is a linear trend. As you can see in here, all the points are lined up and increasing in value. And if I were to draw the line of best fit, which I'm going to do right now, I will try to draw a line that is closest to all the points on the scatter plot. And I see that this is not a very good line of best fit because I have a lot of points below the line. I have a few points that have touched the line, 4 of them, but there is 3 that are only on one side of the line. So I am going to make an attempt to change the position of the line so that the line is closest to most points on the scatter plot. So let me see what we can do in here. Maybe move this a little bit more, just a tiny bit. So I see that I have 2 points above and 2 below. The distance of the points above is a little bit bigger. Okay, so I would say that I am happy with this line of best fit, and I'll tell you why. So this line of best fit has hit 1, 2 numbers, and here is a third one. But not only that, but the number of points that haven't touched the line are equal on each side of the line. So there is 1 point in here and 1 in here. So this is sort of tangent in here, but there is 2 points and then 2 points down here. I am thinking that probably I can move this line a little bit further down because I noticed that this is further from the line than this other one here. So just to make things super perfect here, let's see if we can. Okay. I'd say this is better. Okay, so this is the line of best fit, and now we are going to find the equation of it. Now remember that to find the equation of the line of best fit, we do not need to use the coordinates of the points on the scatter plot, not the discrete point, not the special points. We must use 2 points from the line itself. So step number 1, is choose 2 points from the line. And obviously we want to choose points whose coordinates are easier to identify. So here I go. I'm going to go ahead and make my choices here. I find this point easy to read, so I'm going to call this the point A. The coordinates of A are 0.5, and this seems to be 0.25 here, half of 0.5. So 0.5, that's the first coordinate, the horizontal, right? And 0.25. And I will pick another point, point B. And here is a point B. It's good enough. And the coordinates of it are, horizontal coordinate is 3. And the vertical coordinate is above 1.5, is halfway between 1.5 and, here we go, so 1.5, this would be 1.75, and this is 2, because 1 square here is measures 0.25, right? So this one here will be halfway, almost halfway, 1.5. I would say that's 1.7, because it's a little bit less than half of it. Sorry, here we go. So this is 1.7 and then 1.5. So I would go for 1.6 in here because it's slightly less than. So let me correct this. So 1.6, okay? So once you choose the 2 points, then this becomes a simple problem of finding the equation of a line between 2 points. So step 2. Determine the equation. So the equation will be in the form y equals mx plus b, which means we need to get started with the slope. Remember, one point will be x1, y1, and the other x2, y2. And slope is easy and fun. Just remember to rise and then run. So we have y2 is 1.6 minus 0.25 over 3 minus 0.5. So 1.6 minus 0.25 will be 1.35. And 3 minus 0.5 is 2.5. So this would equal 1 point. We can move the decimal place if we want to do this using mental math. So this would be 135 over 250. And if you want to write this in decimal form, that would be 135 divided by 250 is 0.54. So once we find the slope, we substitute into the equation. And then we start searching for b. In order to find the coefficient b, we will need to use either one of these points. And I'm going to use point b in here. So y equals 1.6 and x equals 3. That will change the equation to make it 1.6 equals 0.54 times 3 plus b. So that means that we have 1.6 equals 0.54 times 3 is 1.62 plus b. So the value of b equals 1.62, 1.6 minus 1.62 actually, because we take this to the other side. So B equals negative 0.02. So we're going to say that the equation of the line of best fit is y equals 0.54 x minus 0.02. Now it is very important that we use the exact variables as indicated on the graph. But I find that very often students find it easier to use the x and the y when finding the equation of the line and then substitute at the end. So if you are one of those people who prefer to use x and y, then there is nothing wrong with it. But please don't forget at the end to replace the independent and the dependent variable with the respective letters used on the grid, because we are creating the equation for this particular relationship, right? So instead of y, we're going to write r equals 0.54, and instead of x, we're writing h minus 0.02. And this would be the equation of the line of best fit. Now moving on to the next example. In this example, we'll learn how to scale the axis and draw a scatter plot. So this time, the data is given on a table of values, and we have to draw the line of best fit. But first, let's plot the data. Now, it is very important when we're plotting the data to choose an appropriate scale, because that would make a good scale makes plotting data a lot easier. So how do I plot the scale? First of all, keep in mind that the age of the car, which is in the first column, will represent the independent variable. And remember that independent variable goes on the horizontal axis. So on the horizontal axis, we will have to fit numbers lowest 1, highest 7. And I will label the horizontal axis as age of car, or age of the car. And I'm going to let n be the number of years. So the second column represents the values of the cost. So that means that cost will go on the vertical axis. And for cost, we're going to use the variable c. So we'll let this be c. Now, since we have to fit numbers 1 to 7 on the horizontal axis, we need to start by counting the squares. 1, 2, 3, 4, 5, 6, 7. I have 7 big squares, so I have enough room actually, and we want to maximize the space, because the bigger the space, the clearer the graph will be. I can even go 8 here, which I will. Now, for the values of the cost, I have to look into the lowest and the highest. So I would say that the lowest data that I have to fit in here is 100,000, and the highest is 35,000. Actually 10,000 and 35,000. So 35,000, I'm checking the number of squares that we have in here is 2, 4, 6, 8. So we can fit 40,000 if we assign 5,000 for each square. So then we have 10,000, 15,000, 20,000. So easy to miss zeros here. And then 25,000, 30,000, 35,000. And we don't need 40,000, but let it sit here. Now that we have a scale, we're going to draw the line, we're going to plot the points. So year 7, 10,000. So year 7, 10,000 means that the point must be somewhere in here. So I will plot it. Now, year 5, 16,000. So we'll go 5, not 15, but 16. So see, this will be 15. So one more square and we hit 16 here. One year, 35,000. So 1 year, 35,000. So higher cost or value, we should say. So 3 years, 18,000. So 3, 18. So this is 15. Each little tiny little square would be 1,000, right? So this would be 18,000. 2 years, 21,500. So that would be 21, so half the square here. And 3 years, 30,000. Interesting. So 3 years, 30,000. Okay. So this is the data set in here, and we need to draw the line of best fit. So I'm going to try to use the area strategy. So this is what happens if I were to enclose this data set, right? And the line that would divide this area into 2 equal parts, I would say would be this. Okay, so I will try to move my line a little bit further down because the data is very close to these ones that are above, not as close to the ones below. So let's give it a try. Because we also want the data to have an equal distance from the line. Okay, so that's what will make them better, or that's what would make this line a better line of, or a line of a better fit. So I think that this is good line of best fit because I see that there are 2 points in here and 3 above, but this is closer than this point in here to the line, and this line in here, this point in here has a smaller distance than this other one. So, and again, there is nothing carved in stone with this, so we have to be logically right, but not precisely right. And that's what scatter plots are about, okay? Predictability more than accuracy. So we have to find the line of best fit, so we're going to do the exact same thing we did before. We're going to pick 2 points. 2 points with easy coordinates to identify. And I am going to pick in here this point. I'm going to call this point A. And this one here, oh, this is a good one, point B. So the point A has the coordinates 6. And if you walk all the way here is 12,000. And the point B has the coordinate 4 and 20,000. And now we have to find the equation, which obviously is in the form y equals mx plus b. We already went over the process in the previous question. So we go slope equals x1, y1, x2, y2. And we'll say that we have 20,000 minus 12,000 divided by 4 minus 6. Now, I want you to think in the meantime, would you expect to get a positive or a negative slope, and positive or negative answer here? So divide by negative 2, we got negative 4,000. So we'll say the slope is negative 4,000. How about the y-intercept? So for this, we're going to use either point. I'm going to use point A, x equals 6, and y equals 12,000. And I find that we have 12,000 here equals negative 4,000 times 6 plus b, which is 12,000 plus 24,000, because then that minus will come to the left positive, and that will be 36,000. So therefore, we're going to say that the equation is, again, let's use the correct variables. So we'll say C equals, maybe I should write it above here so we have no room. The slope of negative 4,000 n, and then plus 36,000. So 36,000, think about it. 36,000 was the value of the y-intercept, which means when n equals 0. So that must have been the price of that car, brand new. Now we have to use the equation to predict the price of the car at 4 years. So if cost equals negative 4,000 and plus 36,000, now in 4 years, that would be negative 4,000 times 4 plus 36,000. So that would be negative 16,000 plus 36,000, or 20,000. And notice that the cost in 4 years is not given in the table, right? But we did have the cost in 3 and 7. So in this case, we found the cost for a value in between the data. That is called interpolation again. The cost of the car in 10 years would be negative 4,000 times 10 plus 36,000. So that would be negative 40,000 plus 36,000. What is going on here? So we got a negative value. What do you think this means? Now, mathematically speaking, finding the value of the car or the cost of the car in 10 years, for this particular data set where we don't see the value of 10 for the number of years, is called extrapolation. So we're trying to find a data outside our data set. Now we're running into a small little problem here. We got a negative answer for the cost. So we don't understand what is going on. What do you think happens in 10 years to this particular car? So it seems that this car has devalued very early, so before the 10-year mark came. And that's why the equation will give you a negative number, because the graph will have to go below the horizontal axis. Now, is this realistic or not? So it can happen that the value of the car is very low sometimes, but we want to keep it running because we do not want to make bigger purchases, so we keep on investing to fix it. So In the real world, yes, it might happen. So we have one more example that I would like to take up with you, and I would like to start this in a new video in part 3 of this lesson. See you soon, and thank you for watching.